Yes, please.
Yes. Okay. And I was like,
Sitting right over here.
oh, okay.
Perfect. Okay, is that better? Thank you very much for being here and welcome to the Houston Maritime Museum. This is a special evening. It's it's the beginning of our industry lecture series that is a little bit of a new venture for us. We've had history lecture series that I think I've seen a lot of you attend before, and we have some new faces, which is very exciting. So first of all, my name is Leslie Boland. I'm the director of the museum. A couple of things that we have to do as part of our accreditation process. We like to keep track of who comes to the museum for lectures, and I have this form. If you don't mind filling it out, putting your name down and how you heard about the event, that would be super. I would like to just quickly, typical housekeeping sort of things. We have some postcards at the front door. If you've not seen them before, please pick them up and hand them to your friends and tell them about the museum. The other thing I would like to do is if anyone here is not a member of the museum, I'd love to encourage you to join, because that's how we keep the door open and how we are able to have these lectures. So there's a brochure at the door and paperwork there. You can go online, etc. So we have lots and lots of things. We have amazing tours here. We can just pretty much do anything you want. So just tell us what you want and we'll do that. And so because we have such an interesting topic tonight, I don't want to delay getting started. I would like to introduce you to Tom Johnson, who is a docent here and a volunteer, and he's the one that helped us put together the concept of the industry lecture series to branch out, and he's the one that came up with this introduction and topic, which is a pretty incredible way to start. So I would like to introduce you to Tom, and then he'll tell you about our speaker.
Thank you, Leslie.
Thank you, Leslie. Well, age has caught up with me. I need the glasses. Thank each and every one of you for taking time this evening to come out and be with us and listen to this, what I expect to be an extremely interesting topic. I myself am an engineer, so there's a couple of engineers right front. We were telling jokes a minute ago. This is like the moonshot for NASA, what these gentlemen have done and what you're going to hear about this evening. Our speaker tonight will be Mr. Jordan McDonald. He's a 2012 graduate from Texas Maritime down in Galveston and part of the Texas A&M University system. He has a Bachelor of Science, Marine Transportation, and an unlimited third mate's license, wherein he sailed on tank ships prior to coming to Titan about 2 years ago. Titan, for your background information, is a worldwide salvage company, emergency response, wreck removal, and it is a subsidiary of the Crowley Maritime Corporation, which is one of the largest, if not the largest, North American marine transportation provider with a variety of marine interests, including Titan. What I'm going to do for about 5 minutes before Jordan steps up is just a little brief pictorial on what is the salvage industry about. It's really the tow truck emergency response experts of the seas, to put it in layman's terms. There's about 8 to 10 significant worldwide salvage companies, of which Titan is one of the truly largest and most accomplished. The scope of the marine salvage industry goes anywhere from removing, let's say, a sunken shrimp boat in the channel, which is a very small effort, to this tremendous effort to raise and remove the Costa Concordia, the largest cruise ship lost in history, and I'm sure all of us have seen snippets of the films on the news over a few years of what happened out there on the coast of Italy. Just as a little bit of background again, there are a number of different technical and legal types of salvage, and we won't go into those, but there's contract salvage, which I'm not sure, Jordan will comment, is the typical no cure, no pay Lloyd standard form of contract that you enter into. And then there's pure naval and plunder to differentiate what goes on in the industry of salvage. It's a unique and challenging industry. You have to understand that vessel designers and builders produce a vessel, and I've recently retired from a shipbuilding company, under the most controlled and safe conditions. They're built on blocks in a shipyard. The weight is supported completely out of the water, many thousands of tons in large vessels, and then very, very carefully launched into the water. The only other time a ship of any significant size is out of the water is when it goes into usually a floating or graving dry dock for repairs. Again, it's very, very carefully orchestrated, and the weight is moved in and placed on blocks in critical points of the hull to support it. Otherwise, it's in danger of failing or cracking. What's important about that is that when a salvage company, like in the case of the Costa Concordia, is faced with an effort to raise a vessel, that the vessel is in fact in the most extreme condition. It is nowhere near what the architects and the builders envisioned, and it's a engineering mystery and a very complex issue to be carefully worked out. The least people are hurt or the vessel further damaged and lost. So it's the most challenging of all engineering efforts that take place in and on the water. Last few comments here. Just a few notable historic marine salvage efforts, and we'll all recognize some of these. In the 1940s, the Pearl Harbor attack by the Japanese, the battleships California and West Virginia, among many other vessels, were salvaged urgently to get back into the war effort. The first application of significant parbuckling, which is a term Jordan will explain to you, used on the Concordia, was actually used on these battleships right after the attack on Pearl Harbor. One of my favorites, the 1974 Hughes CIA Russian nuclear submarine K-129 Project Azorian. Any hands out there? There's one or two. That's when the CIA put together secretly with Howard Hughes a brand new ocean mining vessel of gargantuan proportions to pick up a Russian submarine off the bottom of the Pacific Ocean. It was totally in violation of international law, but we needed something badly that was on that submarine. 2000, the Russian Oscar-class nuclear submarine, the Kursk. I think that's a little bit more current. The Barents Sea was lost, and a competitor of Titan, we won't mention names, brought that vessel and its crew back to Mother Russia. On the commercial side, two to mention, the Exxon Valdez, and most currently, unfortunately, the passenger vessel Swell, if I pronounce it right, car ferry in South Korea, which capsized and was lost with, unfortunately, many young people on board. So Jordan will speak to that briefly. I think his company is going to take a serious shot at that. And with that, please welcome our speaker.
Thank you, Tom, for the introduction. How are you doing tonight, ladies and gentlemen? Good. Glad to hear it. Tonight I will be speaking on the world's largest salvage job to date, and possibly the most interesting and most well-engineered that I've ever seen in my entire life. Which is relatively short. So I'll give you a little background on it. January 14th, 2012, probably a date that will go down in history. Unfortunately, there was a loss of life, 32 people. Another salvage company actually came on to the job first to do the fuel removal. I'm not going to say the name, but it's up there. After that happened, the Italian government went out, Costa, they went out and they said, how do we get this out of here? What's the most environmentally safe way to do this? Well, not to disturb everything and also in a timely manner. So 10 companies went out and sent in proposals and said, this is how we would do it, and we can do it better than them and cheaper than them. So we know who won that one. So after May 7th here, Titan Recovery assumed control of the wreck on May 25th. Oh yeah, I apologize. I talk with my hands. So a little background on the location here. It's off the west coast of Italy. See this tiny little island here, Isle de Giglio. And again, you can notice the very rocky coast on the eastern side. And you can see where the arrow is pointing about the large rock formation there. If you look a little closer, that's actually the Costa. That's a satellite image from Google Earth. And you can see how she came laid to rest right here. She healed over about 70 degrees in about 65 feet of water. Now in this scenario, it actually turned out to be in our favor. If she had gone over to the other side, it would have been much deeper and a much steeper of an angle. As you can see the topography here, this is the worst nightmare situation. As you can see, the two knuckles of granite coming out here, right here and right here. No support in the middle. A nightmare. And so that's another reason that we wanted to get this done as soon as possible, but also taking safety into a huge account. So here's the video proposal that we actually sent to Mike Coppery and to Costa Concordia and said, you know, this is how we would do it. And again, we had only 28 days to prepare this. That's like building a bridge and saying, okay, this is how I would do it in a couple weeks. Excuse me, one moment. So this gives a background of what a pristine community it was. Amazing island. So our first problem we didn't want to happen was putting holdbacks on the ship. So in case weather comes up or anything else happens, she's not going to slide any further down the rock face.
read those phrases to us?
No, yes, sir. With flotation tanks and pulleys in place. Just click on it. The inshore holdbacks will keep the ship from sliding down the rock. As force is applied by the pulling machines, the ship will be resisted from roll. And this is the theory we had going into all of this. Once upright and safe, the platforms can be attached to the holdbacks. The inshore flotation tanks will be floated into place, connections will be made to the plate slings, and the tanks will be filled with water and floated into place. When we are prepared to refloat, the tanks will be filled with air and the vessel will float off the platform. Calculations indicate that the ship will float at about 18.5 meters. With the top portions of the tanks no longer needed for buoyancy, we can take them, put them on the side, and then she'll lift up. Top portions can also be designed to attach on the outboard side, creating more buoyancy if needed.
Looks easy in the picture. So the subsea platform was removed afterwards?
Yes, sir. And site remediation. So that was the idea behind everything. So one of our first major efforts was, how do we make the ship safe to actually get on board and do what we need to do to make the right fittings and get everything ready for part buckle. So here you see, this is how we set up the boat landings for safe access. So we could bring any vessel up to the side here and put our crew on board. Now another thing we wanted to do was retrofit this basically to be our office. We'll be able to work on it, we'll be able to do everything, but again, she's on her side. So everything that was already in place, we had to modify to her list. And here you can see, this is the deck. So we had to make our own walkways and put up new supports because we didn't know if any structural damage had actually twisted, the deck side as well. And here you see our welding cable set up for 40 welders. And those 40 welders did different shifts and they'd go round the clock, 24/7, non-stop. Here's a drone shot of her with the Macapari 30 next to her. That was our heavy lift vessel that we used for installation of the sponsons. And I'll explain those in a second. So here you can see what she picked up on her port side, and this is what initially caused the damage. So this was our first procedure, was getting the rock out of her. And so we took that out and we actually placed it where it was picked up and put a plaque on it just to remember the actual date and everything.
But it was moved in one piece?
Correct.
How heavy was the rock?
About 5 tons. And so here you see the transplant of the Pinot Niblé. This was right next to the wreck site. A lot of the agriculture and whatnot here, as well as the seagrass, we brought in the University of Rome to come in as our environmental team. So everything that you see, the mussels and everything, it was laid out on a grid and taken pictures and cataloged, and then transplanted to another site, and all categorized, so when we moved the vessel, we could bring everything back to the original state. And this is partially why we won the contract. So here you can see the beginning of the part buckling. So this is what we had in mind. The first step were these port side anchor blocks. We wanted to put these on so we could run chain all the way down, come back up, and then put strand jacks on this side, which again, as Tom was saying, is one of the oldest ways to do it, just never to this scale. And here you can see the installation of just how massive these were. So here you see the other parts of the strand jacks coming on board, and those will be fitted to those blocks. And again, our biggest concern was the midship section of the vessel, because that was the least supported. Here you can see the grid we laid out, and this is all the lineups for every sponson, all 15. Of course, we did that in just enough time because the weather picked up. And another part that we had to do was obviously sit there and say, you know, let's prepare for the 50-year storm with, you know, 50-foot seas and everything imaginable, and we still want to be here after.
Was there any vessel movement at all during this?
Slightly, but nothing to, you know, really worry us. So after the weather started letting down, we hopped back to it. February came around, we had installed all the other anchor stops. March 2013, this is when we really kicked into gear and when everything started coming around for us. This is one of our diving control stations. We logged over 15,000 individual dives. So we staged these all over the vessel, and we had about 5 guys to each diver. 5 guys topside for 1 diver down. Now the next part was the anchor block drilling. This is probably one of the most important parts because this is when we put in the strand jack towers. So you can see here the installation. We had to drill straight into granite, which was not an easy task. And these anchor blocks were about 8 tons each.
Is the water really that clear?
Yes, sir. Not just Photoshop. And you can see the tensioning bars here that go on top of the anchor blocks for when the strand jack towers come down. That's what supplies the pressure when they start pulling. And again, you can see this sheer size of these by the diver standing on it. So here you see the towers being installed on top of those anchor blocks. So these would actually come down and sit on those. So once that was complete, we had about 13 and then a 14th on the other side that was partially installed because we didn't know if we were going to have to use it. And you can see how much room we had to work with on this inshore side. So this is when we brought up the whole back chains, and as you can see, you know, those are the anchor blocks there, and they run under the ship, come back around and hook up to those strand jacks.
Is there always room to get them under the ship?
Yes, sir. You saw how at the beginning when it was kind of that midship section was dug out? That's how we were able to send divers down and pull those cables through. Which was not a fun job. And here you can see we covered up a lot of the damaged area. We put about on the ship itself, about 15,000 extra tons of metal, just in securing it. And you see here, it was a difficult surface to work on. So we sent all of our workers to an industrial climbing 4-day course. And during the entire scope of the project, we actually had Italian climbers monitoring and watching our workers, making sure everything was all right. I always butcher this name, but this is where the ship was built. And funny enough, a couple years later, this is where the sponsons were built to salvage her. So here you can see one of the initial sponsons. This is one of the small ones at about 300 tons. And again, most of these materials had to be made just for this. And you can see the connection right here on this side. This is what actually mounts to the ship. So we brought in a heavy lift vessel and started picking these up. This is one of the larger ones at about 800 tons, about 10 stories tall.
Is any of that material reusable, or did you have to scrap it?
It's reusable, yes sir. And here you can see, and everything had to line up within inches of one another. It was very tight fit getting everything put together. So the next portion was, after fitting the sponsons, was when we par buckle and right the ship, what are we going to sit her on? How are we going to get it down? And how are we going to do it safely without breaking the vessel? So as you can see here, we drew up schematics on how to put a platform down. And again, it was just for this midship section. So here you see our strain jacks and everything ready for par buckle. They come under, and the ship should right and sit down on those platforms, even keel. So in order to put those platforms down, we had to do very precise drilling. About 2 meter wide holes, 25 of them altogether. So we had to come up with a template to actually use this and mount everything just right. And here you can see the larger one for the aft section of the platform. So here's the Mike Opry 30 starting to drill. And as you can see, these are the templates here from the first pictures, and the drills actually went down straight into those. Here's the drill heads that we were using. So this is how they all came out. It all worked out very well, and again, it was a game of inches. It really was.
How deep were those?
They would go down about at least 30 feet, at the very least. Those are on the short legs, up to 60 to 70, just depending on the ground and whatnot.
Is that a fish sitting there?
Yes, we found Nemo. No fish were harmed. So here you see, after all the platforms were built, we had to ship them over on barges. And you can see the installation. These weighed about 1,000 tons each, 1,000 to 1,500. Here's the second one going in. And so our next concern was, okay, we roll the ship over onto these platforms, not a soft surface. How's that going to react when you hit that at a high capacity, depending on how quick the ship comes over? So we wanted to do grout bags, a grout spread. And so we put 6 teams together, 66 divers, that again worked around the clock, filling these grout bags with cement and getting everything under the ship. And here you can see the loading. And again, the midship section was one of the big concerns. So we wanted to fill that entire void of where the granite came out with these grout bags. And here you can see them lined up.
Did you have a control rotation speed as far as, you know, the rate that vessel would be righted?
Yes, sir. 3.5 degrees an hour.
Sir,
Yes, sir.
can you repeat back the questions you're being asked so we can hear?
Okay, yes, sir. And that comes up in a second, but it was there going to be a controlled rate to which she was righted? And again, that was 3.6 degrees an hour. So one of the other things that we didn't take into consideration at the beginning was the bow. We have all these other supports and platforms and everything in place for this vessel, but what if she comes over and the neck breaks off? That's what we didn't want to happen. So we put these together. We call them the Blister Systems. And so this came into play. It was about 1,500 tons. And these are all hydraulic rods here. And what we did was we sunk it down. And this is just another, this is how big they were. That's in the middle of town. We had to knock down a few guardrails to get it in. And as you can see here, we flooded all of the tanks and actually brought her under and then hooked her to. And what we did, we took the hydraulic pins and put it through the bow thrusters. So we cleared all that out, put it through the bow thrusters, and then pumped air into her and brought her snug and tight, and then welded on. So as you can see here, here's all the cables coming down off the sponsons, securing to the platform. Now each of these sponsons we had to control manually, so we put ballast control systems, sometimes 2 each, on each single sponson to monitor both air and water. So here we are at the start of par buckling. And here's a time-lapse video of just how we did it.
So you're pulling now from the land side, right?
Correct, we're pulling from
Underneath
land
the ship.
underneath and bringing it back. And around nighttime is when we actually started putting water in the sponsons on the port side to bring that roll around just a little bit quicker, because it took a lot more force to get it up than we thought.
Why 3.6 degrees per hour?
That was the safest way to do it.
I mean, was that in theory, or was that relationship to 1.5 per hour and a half?
In theory, we wanted to do it at a smaller rate, but it had to pick up that quick in order to get her all around.
So what was the total time that it took to write it?
19 hours. She asked what the total time was to ride her, and it came in just under 19 hours.
How long was the total project?
Total project was 2.5 years. So here you can see her finally coming up with the discoloration here after being under for about 2 years. Now as each deck comes up, we also had to do air monitoring and check each deck and see how everything was going.
Were there corpses still in the ship?
There was one body that hadn't been found yet.
As you're rolling, are you pumping water out of inside the hull?
No, sir.
It was probably no integrity.
Correct. So here's where we start pumping water into the port sponson tanks.
Was there any attempt that was made to seal the hull where the rocks where she ran aground, or was that left unrepaired.
Yes, sir. We put a small plate on it, but again, it was, we basically just built a ship around it. So at that point, because we didn't know the extent of the damage on the starboard side.
Were there a lot of spectators?
Pretty much the whole island of Giglio. And anyone with a boat.
Was the whole project pretty much right at budget, or did you go way over, or just a little bit over?
That's a very good question. Was the project at budget? It was a very difficult project in the way
Oh, yeah.
environmental and Italian government. So those two factors alone pushed the project to exceed our expected turnout. And again, I'll hit a couple of those notes at the end. So here we go. We hadn't seen the starboard side. We had no idea how bad the damage was. We had no idea what it looked like, or if it was even there. So here we started cutting away just everything that was hanging loose, so our divers would be able to start installing the holdbacks for the sponsons on the starboard side. And here you can see those knuckles that were coming out of the granite, how far they just dug in. So our first order of business was cleaning the ship, getting it ready. We wanted to be safe for our workers and everyone on board that was having to spend the time to put all the systems into place. So we started doing a lot of power washing and a lot of air monitoring as well, and clearing all the decks. And again, after about 2 years under, there was a lot of buildup.
Are you just flushing over the side into an area that's corralled by slope around it to keep the contaminant off the
Correct.
ocean? Or-
And here we started clearing out the inside. Again, it all goes back to safety and our workers. And you can imagine walking through a sideways ship with a bunch of debris everywhere. So here we go. We're up to winter again. And the government said, well, we can't let it do anything. We haven't put the other sponsons on. So we installed these. These are our holdbacks into where they attach to the sponsons and to our platforms here. So after winter came through, we were ready to install on the starboard side. So we had to modify all of this because all the structural integrity was gone from this side. So we had to put all these holds in, and then again, we had very small operating surface here. So once we got all the sponsons hooked up on the starboard side here, we were ready for refloat. So once we started engaging ballast, we started bringing her up, and she was on the platform here. So we had to shift her over slightly and able to bring down those other sponsons. So here you can see some of the below decks starting to finally come up. And this is her finally afloat. And again, she was only about 3 decks up. She still had 6 passenger decks underwater. Her draft at this point was about 18 meters. So for the tow, we actually had to hire 2 different towing vessels, each of about 180 bollard pull. We hooked those up on front, and then we had 6 escort tugs all around the vessel. We also had a crew of about 52 people on board, monitoring all the tanks, making sure everything was all right, and another 2 vessels in the front and behind of biologists monitoring the water. So here's where we took her back to Genoa, got her dockside, and this is where Titan really ended the project for us. As soon as we got her back here, the Carnival just signed a contract with Saipem, and Saipem agreed to do all the scrapping.
What was the distance of the towing?
About 5 days.
And in miles or meters or?
Oh, she was moving at least 250.
Oh.
300. We did it very slow.
How was the weather during the transit?
Very nice, very nice. We got lucky on that one.
Just like a normal cruise.
That's as high as you got her out of the water
Correct.
in this image.
Yes, sir. So here's some fun facts about the job, everything that went into it. 40,000 man hours of engineering, 530 people working on site, 55 certified welders, 130 certified divers, 15,000 individual dives logged, 27,000 hours of ROV footage, 19,978 tons of grout cement, as you saw in the grout bags, 33,020 tons of steel fabricated. We basically built the Jones Act tanker. 9.3 tons of welding rod, 37 kilometers of weld put down. So I'd like to open the floor to questions, comments. Yes, sir.
When you were rolling it up, when you were rolling it onto the platform, did you have strain gauges or some other measuring equipment on the hull to see what the load was? And secondly, did you go in with a plan of what to do if it broke in half in the course of rolling over?
Yes, sir. So the question was, did we have strain gauges while we were riding the ship? And the answer is yes. We had very small GPS devices lined up every 2 feet to check deflection and all of the strain on the vessel. We made sure they were lined up at least within a centimeter the entire trip. And for the second part, as far as breaking in half, yes, what did we plan if the ship breaks in half? Well, we do wreck removal as well. So that was one of the interesting scenarios for us. It might have been a little quicker and cheaper.
Did you make a profit?
Yes, sir. Did we make a profit? Yes, we did. In total, I can't disclose everything, obviously, but in total, from all of the claims and court cases and everything, the P&I clubs ended up paying out just short of $2 billion. Yes, sir.
How similar or how different from the other proposals was your engineering approach?
From our engineer,
Was this an obvious strategy to take?
not necessarily. There were a couple different views on, mounting pumps and trying to pump everything out and then patch. Again, no one went into the environmental detail that we did, and I feel like that was the strongest factor. And again, Isle de Giglio is a beautiful place, and it was only 500 people as a population. So our team basically doubled the population overnight. And the people were so nice, they welcomed us into their homes and whatnot. So it was a great thing to see, and that's why we wanted to care for it the way we did. Yes, ma'am.
Were you there?
Yes, ma'am. Yep, I spent 4 months on site. Sir.
During the actual running aground, it was my understanding that they ran aground a little bit offshore. This is what I need you to clarify. And then the captain knew that the vessel was in distress, so he ran it in close to shore, and that's where it wound up. And if he hadn't have done that, it would have sunk in a lot deeper water. Can you expound on any of that?
In the small part, basically, how did she come to rest where she did?
So close to shore.
Correct. Yes, it did end up coming back, and again, you saw the rock stuck in the port side there, and that's where initially it struck, and then came back around because he hit the bow thrusters, and actually did bring it back around. Was that his intention? I can't confirm or deny, but it did end up working out in their favor. The loss of life would have been much greater had it gone the other way.
The captain of the Concordia, now he's in jail now, right?
Correct.
And what's his prison term?
Captain Schettino is doing 16 years in prison.
I think he's still out awaiting appeal. I don't think he is in prison right now. That's the latest. And I checked this because I'm, trying to learn about this in anticipation of your talk, but from what I understand, according to the Italian judicial system, he can be out on appeal until all his appeals are exhausted. So I think the scuttlebutt is that he's going to die of old age before he sees the inside of the prison cell.
Well, he won't be having much fun in the meantime, I can assure you that. Yes, sir.
Was your company responsible for removing all that, the platform and all the anchors? And I mean, did you go back and take all that stuff away and return the place there to the condition it was in, or did someone else do that?
For site remediation and taking all the platforms, grout bags, and everything out, we actually had our partners take that one, Macapri, which is an Italian salvage company. So we actually gave the contract to them, and they're actually still working on the site remediation.
Why did it make more sense to ride the Concordia and haul her off to be salvaged rather than dismounting her on the spot?
It all goes back to the environmental. The environmental comes into play with everything, and that was a couple of the other ones, and it would have been much cheaper and faster to do it like that, to cut her up into place and move her from there. But the Italian government and the environmentalists from Italy said they wanted it that way.
Did the company pay all the bills, or did the government pay?
The insurers. Yes, sir, in the back.
Two-part question. I saw that the lightship of the Concordia was about 44,000 metric tons. After you added everything and all the supports on there, do you know what the extra dead weight of everything was?
65,000.
Okay. And then with so there's two parts. Do you know what the ground reaction was there on the two pinnacles on the stern and the bow of the ship?
I'm not sure about that.
Okay.
We actually, when we were riding her, we were off in our calculations. There was a missing 5,000 tons. We said, where is this coming from? Well, we didn't take into account the drapes, the curtains, the bed linens, and everything soaked with water. And that actually added that much weight to it.
Wow.
Mattresses, you name it. Yes, sir.
When you were hosing down the decks to get it cleaned up, basically, all that water from that was going down into the sea, but you had the boom all the way around. Was the water that was being washed over, was that somehow that puddle, that pool, was it being filtered then by machinery to restore it to pristine condition, or?
Yes, sir. We
settled in, or what?
Yes, sir. We filtered everything that we actually removed off the ship. Even when we were drilling, there was an oily residue in the ground. So we actually took everything that we drilled, brought it shoreside, cleaned it, and then put it back into place. So
there was a lot of sophisticated equipment involved in this thing. My question is, did you have to design a lot of this project? Or you had a big warehouse somewhere and you just went and pulled it off the shelf?
A lot of it was designed for this exact situation. You can't really plan ahead for this. And again, this has been done before, but not to this scale. And so we basically took those ideas and then just blew it up to a much larger venue.
Where's your home office?
Here in Houston. Sir.
If you had failed in this operation, and when this was going on, there was a lot of media coverage about what was going on. If you had failed, it would have rolled over and sunk. How deep would that have been? Do you have any idea?
It was 65 feet where she was.
Yeah.
And then she dropped off pretty deep right there, so I'd say at least 150 feet.
She would not have been an obstruction to navigation, she just would have been on the path.
Correct.
It would not be the first ship to ever sink.
Yes, sir.
But you'd have a black eye.
Exactly. Yes, sir.
I'm sure your energy requirements exceeded that the island was able to provide. What did you do for power?
We brought on many, many generators. Many. Probably more than the ship was, bigger than the ship.
Was your contract no cure, no pay, or did you have other provisions?
Yes, sir. We had an LOF open with them. Yes, sir.
As the ship was being scrapped and back in the scrapyard, were any of the parts, pieces, whatever, sold off as mementos that people could buy?
I'm not sure, sir. We ended it right there at the dock.
Could we buy the bell like that?
Yes, sir.
Knowing Carnival the way I do, how many cruises did they book for the trip from the wreck to the Salvage?
There were a lot of vouchers.
Your suppliers, I'm assuming European steel, concrete, local, it stayed in Europe?
Again, we were working with the Italian government, so everything was Italian, basically. And all the shipyards for fabrication and everything like that basically came from the area. Yes, ma'am. Sir.
We can keep asking, what's the salvage value of the ship?
When she was built, it was about 500 million.
Yeah, but what's the salvage value in the scrapyard? Just for a ton?
I'm not sure. Again, we're just the refloaters.
A little bit of inattention, Boston.
I think we could probably, like I said, there's so many questions. When you start thinking about the magnitude of all this, it makes you think, oh, well, I've got one more question to ask. So we'll be here a little bit longer, and but I wanted to first of all thank you very, very much. This was absolutely super. And this is from the Maritime Museum. We're going to change that picture because Lindsay was supposed to be here, but thank you very much for being here. This absolutely awesome, interesting magazine that we will have. We don't have them tonight, but we'll have them if you'll have to come back and get them. And actually, we have our next industry lecture will be about the Panama Canal, what's going on there and how it impacts us. We don't have the date yet, but if you'll stay tuned and look for the e-blast, you will know. But in the meantime, we'll have the next time you're at the museum, if you'll come by and ask us for your copy of this magazine. It's very interesting and it details a lot of kind of what we saw tonight. So we'd love for you to come back and visit us again for our next lecture. I think that, let's see, just for a minor percentage of what it costs to do this, we can build a brand new museum. So keep that thought in mind. I think it's 10%, right, Tom? So for 10%, we're going to be able to build a new museum and it will stay afloat. So thank you very much for being here.